part of a successful strategy for manufacturing optical transceivers, the test efficiency must constantly improve. Volumes go up, and there's always pressure to reduce cost. Agilent has many ways to help you. This video will talk about the EyeMaskHitRatio technique and the AutoMaskMargin feature found on the 86100 DCA. Historically, one or more samples violating the EyeMask indicates non-compliance, independent of how many waveform samples have been acquired. By design, this process captures the worst-case performance of the transmitter over a given observation time. However, this can lead to inconsistent mask margins, as one set of samples may capture an extreme outlier, and another set of samples may not. Mask margins can vary significantly from test to test. Also, the more samples that are taken, the more likely extreme outliers will be observed. Mask margin values are then very dependent on sample size. The following measurements illustrate how the traditional all-or-nothing approach to establishing a mask margin percentage varies from test to test. On a sample size of 100,000, the mask is aligned and the margin calculated so that there are no hits. Repeating this test 4 times gives 4 different results. When the sample size changes to 500,000, then 1 million, and finally to 5 million, you can see that the results are very dependent on the sample size. The more samples that are collected, the smaller the margin percentage becomes. This all-or-nothing approach produces inconsistent mask margins and is very dependent on the sample size. Recent changes to testing standards for mask margin percentage have recognized that this no failed sample allowed approach gives inconsistent results and has the potential to make good transmitters look bad simply because an extreme outlier was observed. Since about 2004, many new industry standards allow a very small but greater than 0 proportion of the total waveform samples to violate the EyeMask. This is commonly known as the EyeMaskHitRatio technique. The most common hit ratio is to allow 1 in every 20,000 samples to violate the mask. For this hit ratio, as long as the sample size is significantly larger than 20,000, susceptibility to outliers are dramatically reduced and the mask margin results are very repeatable. For example, with a sample size of 100,000, the mask dimensions can be expanded until up to 5 hits are observed. If we continue to acquire samples, at 1 million samples, we can expand the mask until up to 50 hits are observed. In the following measurements, the hit ratio technique is used to determine the margin percentage. Again, a sample size of 100,000 is chosen and repeated 3 times. Each time the test is run, the mask is aligned for a target hit ratio of 1 in 20,000. The results are more consistent from test to test compared with the traditional approach. Increasing the sample size to 500,000, 1 million, and then 5 million do not change the margin percentage and give results that are independent of sample size. It is not susceptible to extreme outliers like the traditional no-hit method. It is important to note that the mask margin value is independent of the number of samples acquired even with a very large data set, as one mask hit does not lead to non-compliance. The mask hit ratio process also provides an important opportunity to improve test efficiency. Smaller sample sizes requiring less test time yield very accurate results. Now let's talk about the AutoMaskMargin function. EyeMasks are used extensively to determine compliance to industry standards. It is common to expand the size of the mask to determine not only mask compliance, but also by what margin compliance is achieved. One common yet tedious and time-consuming method of determining the correct mask margin is to sequentially increase the mask dimensions until 1 or more waveform samples violates the expanded mask. The mask dimension is reduced to the largest size possible with no mask violations. The 86100 has a convenient function that quickly calculates the mask margin automatically based on the user-defined hit ratio. With the Calculate Auto Margin button or remote command, the maximum mask margin is determined in 1 step almost instantaneously. Here we see how just pressing the Calculate Auto Margin button does the job quickly and easily. In summary, what did these techniques buy us? The EyeMaskHitRatio technique allowed us to reduce the sample size from 1 million to 100,000, knocking off over 25 seconds per test. Not only was the test time dramatically reduced, but the consistency and accuracy of the data is greatly improved. The Calculate Auto Margin feature saved us 12 seconds per test compared to manually adjusting the mask dimensions for the correct mask margin. For more information on these subjects and to find other ways that the 86100 DCA can reduce your cost of test, talk to your Agilent sales representative.